So we have yet to, again, talk about these percentiles here. So I want to get into those right here. And ultimately, I'm going to compare them to a histogram. And I think I'll use this histogram right here with sleep that we made earlier. So let me get a screenshot of this and that. And actually, this graph is bugging me. Let's cancel. That 10.5 there is still freaking me out. Let's see if we can fix that. Edit chart. And the problem is all of the others are 1 apart, and then all of a sudden it has the same distance for 1/2, which just ain't cool. So horizontal axis, if we just tell it to go up to 11, that should fix it. There we go, that's better. Now it's scaled correctly. Oh, so I'm going to need this histogram here. Summary statistics. All of them to this page. Okay. Now, I indicated I wanted to talk about percentiles, and I've labeled this group here as percentiles, and it turns out there's lots of different percentile. A percentile is just a mark we make where a certain percentage of the data is below that. So for example, the median is also the 50th percentile. And so that's this 7 right here. That's M for the median. 50% of the data is at or below 7, and 50% of the data is at or above 7. This number right here I have called Q1. Quartile 1 marks the edge of the first quarter. Quarter is 25%. So this number 6 here is also the 25th percentile. So I can make a mark here at 6. And I can call it Q1. Q3 would be the 3rd quartile, and a quartile is a mark that you make, so in this case at 8, such that 3/4 of the data is at or below that point, so that's also what's called the 75th percentile. It turns out there are other percentiles on this screen right here. Like the minimum would be P0, the 0th percentile. There's nothing below 3. It is the lowest number. So that would also be called Q0, the 0th quartile. And then the max here, there's nothing lower. That is the biggest number. So 100% of the data is at or below the max. So we could call that P100, or we could call it Q4, 4th quartile. And so what I've identified here are 5 different numbers. So we have the min, and then Q1, then the median comes next, Q3, and then the max is last in order. So I'm going to mark all of those in my number line here. So the min is way down here at 3. And that's just min. M is median. And 10, which ends up the way Google counts, all the 10s end up in this stack right here. But the value of 10 on the number line is right there. That is my max. These particular percentiles or quartiles in order like this are called the 5-number summary. And if we graph the 5-number summary, we can make what's called a box and whisker plot. So to make a box and whisker plot, you first need a number line. On your number line, you mark the min, the 1st quartile, the median, the 3rd quartile, and the max, right? 0 percentile, 25th percentile, 50th percentile, 75th percentile, and 100th percentile. And what you do is you use Q1 through Q3 to draw a box. So that's the box for the box and whisker plot. You make a line wherever the median falls. So the median falls right here, happens to be in the middle. It's not always exactly in the middle of the box. It depends on the data. And then you draw whiskers out to the max and out to the min. And what this shows us is 25% of the data lives between 3 and 6. So 25% of students sleep between 3 and 6 hours. Another 25% of students sleep between 6 and 7 hours. Another 25% sleep between 7 and 8 hours. And the last 25% sleep between 9 and 11 hours. So what I have is most people sleep in this narrow range, 6 to 8 hours. There's a few people who sleep way less than that and a few people who sleep a bit more than that, right? 25% sleep more than 8 hours a night. That's what this tells me right here. And often it's helpful to understand how the data is spread up to draw a histogram and a box plot above or below with the same scale. So often what I'll do, I don't have access to any software that does this easily. So I usually have to draw my box and whisker plot, but there are box plot builders out there. So that's what we'll try next is a box plot maker. And then we'll compare it to one of our other histograms we've done. So 5-number summary, percentiles and quartiles. We'll talk about other percentiles in the next class. Well, let's see, what else have we done? We did the heights. Yeah, we could do it on this one right here. So what we're going to do is instead of drawing this by hand, I'm going to show you a box plot maker, which makes a graphical one for you. The downside of the box plot maker is you have to take a screenshot of it if you want to use it. So I'm going to do the following. Let's see. I want to take this chart and I want to make a copy of it. Is this what I really want to do? I think so. And then I'm going to put it in a new Google Doc. So again, I went to the 3-dot button and I said, please copy the chart. And now I'm going to go make a new Google Doc. So I encourage you to do the same thing. I don't think I need to share this. And I'm just going to paste it in there. And linked just means that if you make a change to the chart in the spreadsheet, it'll update the change in the Word doc, which is kind of cool. If you do it unlinked, then it's just a picture of the chart. And if it changes in the spreadsheet, it doesn't change here. So often I do linked, but not always. Okay, so there's that right there. Next, I want to have a computer generate a box plot. Now, Google, let's see, as of last quarter, didn't do box plots. I'm pretty sure it doesn't now. So if I were to highlight the data and go to the chart and ask for a box plot, I'm pretty sure that's not an option. Excel kind of does them, but not really. And that's not the right kind. That's a candlestick chart. Okay, so Google still doesn't do them. So the place we're going to go is a place called StatKey, which I had linked to last class, but I'll bring it up here and share the link with you. Whoa. Oh, I must have mistyped it. StatKey. That's not the right website. That's the one. Okay, so I'm going to put this link in the chat. And for those of you online, either search for it. Come on. I copied it. There we go. So if you check the chat, there's this page I'm on here. And the one quantitative variable option is the one where I can make box plots. They have a bunch of predefined data here, but I want to load our data in here. And then once I have it in there, I can say, hey, make me a box plot, and then I'll explain it. So I need to go back to my average person. And in this case, I don't want to highlight the whole column. I think that'll mess up the program. I want to start at the top and then just go find the bottom and then copy it. So remember, the trick to get from the top to the bottom is Control-Shift-Down arrow on most computers. On a Mac, it might be Command-Shift-Down arrow. So once I've copied that, I can go to StatKey, edit data, delete what's there, paste in your data. Before we hit OK, a couple things to check. Does your data have a header row? Answer is yes, so that box should be checked. Is there a column next to this that says whose height those are? Answer is no. So you got to make sure the right boxes are checked, otherwise stuff you don't want will happen. So again, I do have a header row. If you didn't highlight the word height in inches, then you don't have a header row. I do. Definitely no first column identifying each number. Okay. It makes a dot plot right away. They have a quick histogram builder where you can quickly change the number of buckets. Or like in Sheets, you could go set whatever you want. So I could do something like start at 52, end at maybe 80, and then let's see, pick some kind of range. I can't remember how many we had. Maybe there were 16 buckets. Kind of looks like the one we had earlier, but that's not why we're here. We're here for the box plot. So here's the box plot. These starred numbers mean this computer program thinks that that number is unusually low and this number is unusually high. Those happen to be the min and the max, right? And there could be other numbers besides the min and the max that are unusual. So this 52 seems low compared to the rest. So here is a quick box plot, and the scale goes 55, 60, 65, 70, 75. In order to use this with in my Google Sheet, I have to take a screenshot of it. You could try to right click and save the image. That does not work, so don't bother. So if you're on a Windows computer, screenshots are with the snipping tool. I can't remember how to do this on a Chromebook. On a Mac, I used to know how to do it on a Mac. Hit me up later if you need help doing a screenshot on your computer. So I want a rectangular snip, new, and then I just click and drag over the part I need. Then the trick is lining it up. So now I can copy this screenshot and put it in here underneath my spreadsheet. And then I just want to line it up so that 55 here lines up with 55 here, 75 here lines up with 75 there. So let's see, to do that, I probably need it to wrap. Jump to the next page. Uh-oh, where'd my other one go? Oh, that one needs to wrap too. Okay, undo that, that didn't work well. I should wrap this one first, maybe. And then wrap that one second. And then I should be able to just adjust it. This one's a little too wide. And again, I want 55 is about right here. I want those to line up almost, and then 75 almost lines up there. It's probably as close as I can get it here. And then I'm gonna squash it too. $75, $55, not too bad. So sometimes it's a little tricky getting to line up. Sometimes instead of doing them directly in a Word doc like this, instead what I'll do is I'll insert a drawing and I'll do it in the drawing. Sometimes that's easier to get things to line up with each other. But often it's helpful to have a box plot lined up with a histogram to kind of see what's going on with the spread. So what you should see is that anywhere you have a narrow region, narrow quarter in your box plot, what you should find is that's where the taller stacks live. And anywhere you have a longer quarter in your box plot, then you should find that's where the smaller stacks are. So it's just a graphical representation combining two different graphs. All right, that's it for now. So we've covered almost all of the major topics in section 7.2. There's a few more things I need to talk about with respect to the box plot and how StatKey identified 52 and 78 as outliers. It's different than the 95% rule. So we'll talk about that next class. And then the procedure we took here where we make a histogram that we think is reasonable and we calculate all the summary statistics, and then we try to describe to somebody what this tells us. What do these summary statistics tell us about the data? So the application, the activity this week is to take a data set and then based on that data set, make some histograms, calculate all the summary statistics, and then write a paragraph describing what all this summary stuff tells us about the numbers that we have. So we'll do a couple of examples of that next class so that we can get that activity done together. All right, so I'm gonna stop here.